we'll move on to our next competitor, which is Jamie or Jun Lee, PhD with Heine's group, and she'll be talking about hybrid piezo and magnetic self-sensing actuator for soft robotic applications. So Jamie, whenever you're ready, 3 minutes are all yours.
Perfect, thank you. Hello everyone, my name is Jamie Lee and my research is in the field of soft robotics. So first things first, when I say soft robotics, what do I mean? Soft robotics is a field of emerging research that focuses on replacing these bulky, stiff robotics with flexible materials. There are many different applications to this, such as medical implants, smart textiles, and as you can see, many more. It's a research to turn the traditionally viewed stiff movements and large bulky robotics into flexible and small devices. It's a way to mimic complex movements that robots couldn't do before, like an octopus tentacle moving or the movement of a worm. So my research involves altering the material itself to its nanostructure. It's the development of a thin, flexible material that can both sense, which is the piezo part, as well as actuate, which is the magnetic part. So inside the material, we have these thin, long carbon nanotubes, or CNTs, as well as round, spherical, magnetic iron oxide particles. Once we functionalize the CNTs, we can tightly attach these round magnetic particles to the CNT surface. So what's great about this is when we align the magnetic particles to its north and south poles, first, the aligned magnetic particles is good for its magnetic actuation, and secondly, the tightly attached CNTs will follow suit and they themselves can also be aligned. The alignment of the CNT will also align the dipoles, which is the positive and the negative ends of the material, which is good for its sensing ability. So therefore, when we actually put an electromagnet here, which will apply a magnetic field, the material will have a magnetic actuation downwards due to its clear north and south poles. And once the material moves, the positive and negative ends, the dipoles, will get closer together, almost squishing together. And the material will sense that. The more the material moves, the more squished these ends will be, and the more the material will sense. With one material, this process can be a simple feedback loop where if the material didn't move its intended amount, maybe due to environmental factors, the sensor can detect this and tell itself that it needs to move more. This is a hybrid system that gets rid of having two separate bulky actuator and sensor and trying to integrate them all together. It combines both into one simple single material. So this may seem like something way into the future, but here are my works as well as work from my lab mates that prove that soft robotics is right now. From a simple morphing device for aerospace to something origami inspired to a crawling robot, even electrically activated. With this research and many more like it, the traditional stiff or bulky view of robotics can become more flexible. Thank you.